Hello students, today we are going to learn about the concept of capacitance, and then we will learn that how clock pulse is developed by the help of a capacitor. Clock pulse, we will learn that when a flip-flop is clocked, then a short pulse of electricity is given to that flip-flop. So how that short pulse is developed by the help of capacitance, that we will learn. Okay, so what we are going to learn, that how that clock signal is generated. Okay, and we will also learn that why capacitance is infinite resistance for direct current while low resistance for alternating current. Okay. And by an easy analogy, we are going to learn this thing. You will easily learn that how clock pulse is generated. Okay. Now, you know what is clock pulse. This is a diagram of asynchronous counter. In case you have not checked out my asynchronous counter, then the link is over here. It is clocked like this. You can see the clock is coming and digits are changing. Okay, so like this is the decimal. Okay, so clock is a very short pulse of electrical signal which changes the value of q and q naught of the flip flop. Okay, now, what is a capacitance? Here I am taking an example of parallel plate capacitor. You can see there is a battery and these are two parallel plate metallic plates. Okay. So right now you can see that switch is not closed. The circuit is open. So both the plates will have equal number of electrons and protons. Both the plates are neutral. So we can assume that both the plates contains same amount of negative and positive charge separately. Both are neutral. Okay. Now, in case this key is closed, what will happen? The battery will take the charge from this left hand side plate, since this is the positive terminal. So it will take the electrons from the left hand side plate and ultimately move it toward the right hand side plate like this. Now, a question arises that electrons are transferring from the left hand side plate to right hand side plate. Battery has potential difference of V1 minus V2. How much charge will we transfer? Okay. So the analogy is like this. Suppose that this is a tube. You can see these are two tubes and a pump is connected at the bottom. One pump, okay, and the top of the tube contains air and ultimately the upper end is closed. So it is filled with air, okay. So my question was that when battery is transferring the charge from left hand side plate to right hand side plate, then how much charge transfer will take place? It will be infinite or there is a limit, okay. So you can assume like this, that in case this pump is made on, then since this pump is taking water from right hand side and pushing it toward left hand side, so what will happen when water will rise up? So this will compress the air in the left hand side tube. However, here a vacuum will be created. So what will happen, that this pump will have some capacity up to which it can raise the water, because this compressed water will push the water back. Similarly, this vacuum over here will try to pull the water in upward direction. So this pump has some capacity, some strength. Up to that point, it will transfer the water, then it will transfer no more water. The same will happen with this system also, that battery has a finite potential difference. So according to that potential difference, the amount of charge transfer will take place. The formula is Q equals to CV. Okay, V is the potential difference, V1 minus V2, and C is the capacitance of this parallel plate system. Okay, this battery is a DC source, direct current source. In case AC is applied to this parallel plate system, parallel plate capacitor, what will happen? In AC, what happens, that the terminals frequently changes, means plus minus minus plus plus minus minus plus. So in case we take this pump analogy again, then it is like this. Okay, so we are just reversing the flow direction continuously. Okay, so what we have learned, that capacitor renders infinite resistance to DC. Infinite resistance means what? That once the capacitor is charged, you can see over here, once the capacitor is charged, after full charging, this parallel plate capacitor will act as an infinite resistance, no more current will flow. Okay. Now for AC, you can see that though the direction is continuously changing, the current direction is changing, still there is movement of charge. So we can say that for AC, the capacitor doesn't offer infinite resistance compared to that of DC, for which it offers infinite resistance. Now we will take an example. Suppose that this is a capacitor in series. You can see a battery, this is the switch, and there is a bulb in series. Okay, so in case this switch is closed, you know what will happen? For a short while, this bulb will glow and then it will become off. Very short. It can be in milliseconds or microseconds, depends upon the capacity of this capacitor. Can you tell what is the reason? Because the current will only flow up to the time this capacitor fully charges. That time is a very short duration, depends upon the capacitance of this capacitor. Okay, so for very small duration, the charge will flow. Up to that time, this bulb will glow, and then once the current stops flowing, the bulb will off. Okay, now we will learn that how clock pulse is generated. This property is used. Okay, see, this is the JK master slave flip flop. This is you can see these blue wires are connected to this master slave flip flop to this battery. This blue wire circuitry is to keep this master slave flip flop in on state for its own power requirement. Now one more wire is going, and then a capacitor is connected in series. There is a switch, and then after that a terminal is going inside to the clock point of this master slave flip flop. Okay. Now what will happen in case this switch is closed for a short while, it will become 1. So you can see earlier it was 1 0. Q and Q naught were 1 0, and now 0 1 and then stop. So this operation occurs for a very small duration of time, can be millisecond, microseconds, I already told. So this is how a clock signal is generated. Now in case I am not using this capacitor, only a switch is there, what will happen, in that case the Q and Q naught will start toggling like this. Okay, so even for half a second or 1 by 4 second, in case I am keeping this switch on, then we don't know that what will be the state of Q and Q naught of this JK master slave flip flop. So this clock signal must be of very small duration of time. So this is what the fundamental behind the development of clock signal. So hope by this small lecture you would have understood that how clock signal is generated from flip flops. Thank you.